Recently, I visited a clothing company. It mainly deals with group orders and has encountered a bottleneck in the process of digitalization. After communication, it was found that the main reason was that the CAD they used in the past was a free pattern making mode, which was not parametric. In fact, the patterns were unstructured data. Then I introduced to them the benefits of parameterization. Parameterization actually means that there is a parametric data model behind each pattern, so it is better structured data and data docking can be achieved through the parametric data model. However, when it comes to realizing the automatic docking and conversion of this data, their pattern makers have some concerns. They think that the free pattern making way is better, but if each pattern maker makes patterns in their own way and each has their own set of pattern making logic, then the company has no way to establish data standards. During the process of using parametric CAD, the first step is to establish the digital standards within the enterprise. For example, for a pattern, we need to define what standards it has, what parts and positions the pattern has, how each position is defined, what these names are, and what special body data we need to establish. Which parameters control these special body data? Once there are standards, within an enterprise, pattern makers will make paper patterns according to the same standard. In this way, the digital integration of the whole process can be achieved, and the data exchange between the upstream and downstream can be realized. It can automatically dock with the ordered data and the data center. After an order is placed, it can automatically match the pattern size, automatically grade the pattern for different sizes, automatically allocate cutting beds, and automatically arrange the layout according to the ordered data. The whole process can be completed without human intervention. In addition, after using this parametric system, not only can the digitalization of the whole process be achieved, but there are also many advantages. The time spent on clothing pattern modification in clothing enterprises is often even longer than that on pattern making. In the past, when using free pattern making for pattern modification, it was rather slow. Traditional pattern modification required adjusting one point at a time. After the modification, we had to constantly measure with a ruler to see if there were any errors. If there were errors, we had to keep making adjustments. It was easy to make mistakes. For example, when modifying the front part, we also needed to modify the lining part, then the main body, the front and back pieces, sleeves, colors, and so on. The time for pattern modification was relatively slow. However, when using parametric pattern making, whether through the size table or through local adjustments, the automatic change of the pattern can be driven in a linked and animated way. When we modify one part, other related parts will all change automatically. For example, if we modify the bust size, the sleeves, colors, front fabric, and interlining will all be modified synchronously. After parametric modeling, a base pattern fabric can be formed. When there are new styles in the future, we can directly use the base pattern library. In addition, a component library can also be established. We can use the base pattern library and the component library for rapid combination and matching, so that new patterns can be quickly generated, greatly improving our pattern making efficiency. This system is not only friendly to group clothing, but also particularly friendly to individual customization. If we need to repeat an order, we can handle the order fully automatically. In this way, it can help our enterprises achieve flexible production, realize the quick response model, and customized transformation.